Chapter 1.13.3 Operator Pattern. Summary. Operators are special components in Kubernetes that automate application and service management by using a custom resource. They follow Kubernetes principles leveraging the control loop mechanism. The operator pattern emphasizes automating tasks traditionally done by humans with deep application knowledge. This includes deploying applications, managing backups, and handling upgrades beyond Kubernetes' built-in capabilities. By using the Kubernetes API, operators extend its functions without modifying core code. They enable customized automation like setting up persistent storage, managing database configurations, and ensuring applications remain updated. Operator pattern. Operators are tools that enhance Kubernetes by using custom resources to manage applications and their components, following Kubernetes principles like the control loop. Motivation. The operator pattern is a concept that seeks to mimic the role of a human operator managing services by using code. By understanding how systems should behave, human operators manage and troubleshoot applications. Kubernetes users favor such code automation to simplify recurring tasks. Operators in Kubernetes. Kubernetes comes with built-in automation capabilities to simplify deploying and running workloads. It allows users to automatically manage their environments without manual intervention. Through the operator pattern concept, Kubernetes facilitates the extension of cluster behavior. This feature allows developers to add new functionalities without altering the core code of Kubernetes. Operators in Kubernetes are specialized clients of its API, functioning as controllers for custom resources. They enable users to customize how Kubernetes operates based on specific needs. An example operator. Operators automate tasks in Kubernetes, like deploying apps, managing backups, handling upgrades, and more. They can publish services to apps not supporting Kubernetes APIs. Operators can simulate failures for resilience testing and manage leader elections for distributed applications without internal processes. An example of an operator uses a custom resource named SampleDB, configuring it into the cluster with a deployment ensuring a running pod containing the controller. Operators use controller code to ensure the Kubernetes environment matches configured resources by querying the control plane for SampleDB resources. When a SampleDB is added, the operator sets up database storage and configuration. On deletion, it takes a snapshot and removes resources. Regular backups are managed too. Operators need additional code to provide automation, including checking database versions and creating jobs to perform upgrades when necessary. Deploying operators. To deploy an operator, you usually add a custom resource definition, CRD, and a controller to your cluster. The controller is similar to a regular containerized application and typically operates outside the control plane. You can integrate it into your cluster as a deployment, allowing it to manage custom resources effectively. Using an operator. The code uses kubectl to get information about the configured SampleDB databases and then allows for manually editing the settings of a specific database named example database within the SampleDB custom resources. Deploy an operator and manage resources by adding, altering, or removing them, keeping it straightforward for operations. Set up a deployment for the operator, and it handles maintaining and adjusting resources efficiently without further input. Writing your own operator. Create your own ecosystem operator if needed. Use any language to serve as a Kubernetes API client. Libraries, tools, Charmed, Java SDK, COF, CubeRS, etc. Note: projects are third-party and require a content guide.